Starting with the seesaw mode, this is based on the Yamaha CS80 and it models the inaccuracy in that waveform. So here's a sequence. Moving the timbre and colour, we'll hear this notch and that inaccuracy in the waveform move. With an envelope modulating a VCA and a filter in the patch, this works great for subtractive synthesis. This mode is a variable waveform which was first found on the RSF COBOL and it's since been used in various older and newer Moog synth designs. It moves between classic analog waveforms, sine, triangle, saw and squares, and the timbre morphs between those waves. The colour then gives us overdrive and also some slew limiting. This is a sawtooth and square wave mode with pulse width modulation. PWM on a square is common, but we've also got it on the saw wave here, which is found in some of the Roland Juno synths. So here's those waves. And here's some modulation of those with CV. The first sync mode is a dual oscillator square wave hard sync mode. The colour moves the crossfade between the first oscillator and the sync sound. The timbre moves the tuning of that second oscillator in the sync patch. Modulating the timbre with the main envelope in our patch gives us some classic sync lead sounds. Taking the modulation out for now, we've got a dual saw wave sync with the same controls. The fold mode is a sine and triangle wave folding based mode, and this is based on the wave shaper section in a surge modular system. The timbre controls the fold amount, and the colour controls the mix between sine and triangle waveforms. This is a set of sine waves based on a C-Sound software patch. We've got a mix of sine waves on the timbre, but the latter part of the timbre now mixes into some combs. The colour controls the detune between the waves in the patch. We're now on to the triple waveforms, and we start with 3 saw waves. The coarse tuning sets the master tuning as usual. And then the timbre and the colour control the tuning of 2 other oscillators used in this patch. And we can push this onto other intervals as well as go for a softer detune. These saws provide a lot of content that sounds great with a filter. We then move on to 3 square waves. We've got a much softer warm sound of 3 triangles. And then the pure and clean free sine waves. Here's the ring modulation mode based on 3 sine waves ring modulating each other. The pitch of the second oscillator is set by the timbre, and the third by the colour. And there's loads of different tones in there. This is a super saw patch based on the Roland JP8000, which we now know as the anthemic trance-like sound. We've got the wave detune on the timbre, and a high-pass filter on the colour. Here's a longer envelope for the VCA. And it's great for bass as well if we tune that down. This is a saw wave and comb filter delay. The timbre sets the tuning of those comb filter delays, and the colour sets the feedback. With an LFO into the timbre, we can get flange-like sounds. This waveform is based on circuit bent toys, and the internal clock rate that runs the virtual circuit moves from hi-fi to low-fi on the timbre knob, and the colour sets the bit crushing. So this is great for a really filthy and dirty sound. The next 4 waveforms are phase distortion based, and this is modelling the Casio CZ series and also the Roland D50. The CZ range from Casio was their answer to the Yamaha DX series and can provide some similar tones. So here's this virtual filter. You've got waveform select. And we can tune in this nice resonant peak. This works great for bass. The next mode is then a peak filter, and listed the difference between that low pass mode. The timbre and colour set the same values. Here's the bandpass. And a high pass. And here's the difference between them all. We then move on to 3 different vocal simulators. We've first got a voice simulating circuit that's got partial delays and frequency morphing waves with sync and FM techniques which create these vocal-like peaks in the waveforms. The next mode is a 1980s based speech synthesizer, and the timbre deals with the vowels A, E, I, O, U, and the colour morphs between male and female style formants, and this mode's actually created with granular synthesis at its core. final vocal mode is a vowel-based speech synthesis technique, and we have the vowel and the male and female formant control again. But this one works through a variable filter matrix containing soft palate filters, nasal cavity filters, a glottis filter, tongue filter, and then a lips and teeth filter as well, aiming to model that human vocal tract. Here's the three FM modes, and the first mode is based on John Chowning's form of FM used in the Yamaha DX series synths. We've got the FM modulation depth on the timbre, and the colour modulates the frequency of that modulating oscillator. It's really easy to fine tune this into some harmonious and musical tones, as well as more dissonant tones as well. Modulating the timbre with an envelope works great. The next mode is an FM feedback mode, which feeds the output back into the input of the patch. It's grittier and richer and slightly more saw-like in sound. Controls are still the same. And again, envelope modulation works great. The third and final FM mode is a more chaotic and unstable form of FM. This is an additive harmonic mode. The timbre controls the harmonic frequency and the colour changes the bandwidth and distribution of those harmonics. It's great for pulling out timbres that can move higher up in frequency content and actually move away from that root note and be modulated back again. This is a car plus strong synthesis mode, creating a plucked string sound. The timbre controls the length of the delay lines and the length of the feedback, creating longer ringing notes. Although Braids isn't polyphonic, with these longer ringing notes you can create 4 notes that overlap and bleed into each other, which sounds like some sort of polyphonic strummed pattern. The colour changes the plucked position of that string, and you can think of this as plucking a guitar string right by its bridge and then moving to plucking that up by the neck. And the tones would vary by doing that, and they do move in the colour. This is another physical modelling synth again, based on string modelling, but this is more in line with cellos. It's modulating a bowed sustained string sound. The timbre affects the friction of the bow on that virtual string, and the colour the actual bowing position. And this works great with a filter as it's got a lot of harmonic content. Here's the third physical modelling patch, and this is based on a set of pipes. The timbre controls the air pressure and the colour controls the instrument's geometry, which is its shape and structure. And this almost sounds like blowing into a bottle or a panpipe. And you wouldn't think something panpipe-like would create a dubstep bass sound, but check this out. Moving on, we've got a flute mode, which is definitely more flute-like in tone and structure, but it's really gritty and noisy, which I love. With a short amp envelope, we get some nice plucks. Moving on, we get the bell mode, which is based on additive synthesis. The timbre controls the dampening and the colour controls the inharmonicity or the dissonance in the sound. It's based on a bank of 11 sine waves. And it sounds a little bit like those FM bell tones in some of the classic digital synths. We've then got a drum mode, which is similar to the bell but based on 6 sine waves and narrow bands of noise. The brightness comes from the colour control and the dampening from the timbre. Here's the drum modes, and here's a model of an 808 kick drum. The resonant decay and amp envelope is on the timbre and the tone is controlled by the colour. We've got it tuned higher and we can get some cool tom-like sounds. But tuning that low, we'll get some nice fat kicks. There's plenty of options to sculpt that beyond a basic kick. We've then got a cymbal generator, which is 6 modulating square waves, and then it's also a bandpass and high pass filter controlled on the timbre. And a linear feedback shift register for clock noise on the colour. And we can mix these square waves with the noise. And it's great for not only electronic cymbals but almost cowbell-like sounds and percussion too. There's then an 808 snare. The timbre controls the mix between 2 sine waves and the noise and decay is on the colour. So there's the classic 808 snare. We can affect that with a tune-in. And this is also good for some noisy tom-like sounds. Now we'll look at the wavetable modes on Braids. The first wavetable mode has 20 different wavetables selected on that colour knob. We've got things like choirs, PPG waves, organs, drones, and a lot more as well. And we've then got the timbre that moves through the actual selected wavetable. The second wavetable mode is a wave map, and this is a 16 by 16 grid of completely smooth, interpolated and crossfading waves. The timbre and the colour control the X and Y positions in that grid of wavetables. So let's modulate this. We then move into the linear waveform scan mode. The colour selects the interpolation between rough or smooth morphing, and then 12-bit and 3-bit movements between the waves as well. The timbre controls the scanning through those wavetables. We can smoothly scan through, or have steps and rough changes. We've then got the bitrate changes on the right hand side of the knob. The fourth wavetable mode is a wavetable chord mode. The timbre controls the wavetable morphing and the colour controls the chord type, from various unisons, fifths, octaves, major, minor, seventh chords, and plenty of other chord voicings as well. To wrap up the different modes, here's the noise types. The first noise type is digital noise running through an Oberheim SEM style filter, and the timbre affects the filter resonance, and the colour affects the filter type. The second mode is a twin peaks noise, and the colour spreads these two resonant peaks in the distances between each other, and the timbre controls the resonance. So this is great for percussion. The next mode is a clocked noise mode, and the timbre controls the cycle length, which is the loop points within that noise, and the colour controls the bit quantization. And these noise modes also track pitch as well. So this is very Atari and Commodore 64 in sound. We then move into a granular cloud generator. The grain density and the overlap of those grains is set by the timbre, and the grain randomization by the colour. So again, that's a very different type of noise. We've then got a particle system simulator, which is another granular synthesis noise type. So instead of a cloud of noise, it's almost like a set of little digital critters, which is quite wet and gargling in sound. So sonically at these settings it's not quite there, but this is similar to raindrops hitting water. And the final noise mode is a telecommunications based data transferred mode. It's based on how modems and fax machines used to send data over phone lines. plenty of modulation. You could probably recreate that old dial-up internet tone that you used to hear if you picked up the phone while you were using dial-up internet and actually listened through an old phone line. Let's walk through the rest of the Braids features, aside from the vast amount of modes we've gone through. Pushing the encoder, we go into the menu system, which is a really basic and quick menu system to use. Scrolling through, we go to the meta mode. Turning that on, the FM input becomes a CV input to flick through the different wave modes. I'll grab an offset CV from shades to the right and then scan through the modes with that. So you can see the CV is flicking between those modes. I'll take a random voltage from a sample and hold and add that to the FM input. Much more musically useful to create a specific sequence and have certain steps in your pattern select different modes rather than just flick through with sample and hold. And for ease, let's stick with the sample and hold, and let's go into the menu and look at the bit rate. This affects all the waves, and there's also a sample rate. So it's a nice crunchy digital edge if you want it. Trigger source, which affects things differently across the different modes, can be external or automatic. Automatic will self-trigger when it detects a pitch change at the 1 volt per octave input. Adding a trigger to the input now, we can have a trigger delay set by micro or milliseconds. And then there's an attack and a decay amount for the internal envelope, which can affect the FM. Here's playing with that envelope. You can affect the timbre in all those modes. And the colour. There's also an onboard VCA that we can turn on and have an internal envelope affect the VCA's amplitude as well. This effectively turns Braids into a full self-contained synth voice. Going back and turning meta mode off, we can use the FM input to actually frequency modulate these different modes as well. With a cleaner sound, we'll hear that bitrate and sample rate a little bit clearer. We've got range, which controls the range of that coarse tuning knob. We've also got an octave transposition, up or down 2 octaves. We've then got a quantizer built in, and that will quantize incoming CV at the 1 volt per octave input, which is set to pitches in various scales. Taking a sample and hold into the 1 volt per octave input, let's listen to that random unquantized CV. Turning on the quantizer, this can be one of lots of onboard scales, and you can see some of those from Bob Borry's manual showing on those scales on screen too. We also have a note selected for the root note in the scale. Flat will apply detuning in the lower and higher frequencies to recreate some imperfections in some analog VCOs. Drift will model a poorly designed VCO, or more subtly we can use that drift to create some analog warmth. The sine is a signature glitch specific to each mode, so here's taking the pitch out. Let's select a different wave mode. sign here then adds a different glitch and character, which effectively more than doubles the potential tones in the module. We've then got Calibration, which can read some incoming CV levels, which is a great utility to have in the module. So it's a really simple module that's got masses of tones in there. It's got a really simple menu to use it as a full synth voice or as part of a bigger patch.